So now we are going to discuss something very new about current. See, have you ever seen fuse bulbs? What would you notice or observe in the fuse bulb is that the filament would be broken or melted, or in other case there would be a burning black color which might occur anywhere near the filament or at the points from where the bulbs are attached with the holder, right? Now what is this causing heat? What exactly is causing heat? See, that is why we are going to study about heating effect of current. So current produces heating effect. This is for sure, but how? I'll tell you it in two ways. Number one, that consider the same example, atoms or molecules of the conductor and the electrons which are flowing, the free electrons or conduction electrons which are flowing in this wire. What exactly is happening here is these electrons are actually under constant collisions with the atom or molecules of the constituent conductor or with the walls of the conductor, right? So that collision brings up heat in the conductor. So whenever there is a current flow in a conductor, there will be heat associated with it. Heat becomes more as the resistance is more. Simple. More resistance means more number of collisions, right? So we must also have some formula for heating effect of current. See, I'll explain you this thing again. We know that a cell, let me draw a circuit. Suppose there is a very simple circuit, this and a cell. This cell provides the flow of current in this circuit, but this cell has what? Chemical energy stored in it. The chemical gets depleted, due to which it creates a potential difference across its ends, and that potential difference offer the flow of electrons. So this potential difference, which is making the electrons flow from one part to another, is coming from what? It is coming from the chemical energy stored in the cell. So that chemical energy is getting depleted. So that energy will also be consumed somewhere. So the total energy which is dissipated from one part, according to law of conservation of energy, will also be get utilized at some other part. So what is happening? The total energy is actually consumed in two ways. The major part is consumed in doing the useful work done, for example lightening the bulb, switching the fan on, or rotating the fan, right? All these are mechanical works, and the rest part of the current is produced or is wasted in the form of heat. So that is what we mean by heating effect of current. So let's derive a formula for heating effect. What are the formulas do we know till now? First of all, we know that current is rate of flow of charge, total charge is n number of electrons into electronic charge. Then we know V is work done upon charge, and then we know voltage is current into resistance. Okay. Now the energy, as it is always associated with work done, work is equal to energy. So whatever energy is stored in a body, it will be equal to the amount of work that can be done by the body, or in other words, the work performed by a body is stored in terms of energy in the body, right? So I want to know the value of work done. Okay, so I can do it in terms of power. Power is rate of doing work upon time. What is work? Work is potential into charge, so it will give me V into Q upon T, but Q upon T is what? Current. So power is V into I. This is the formula for power. Now work done, we have a formula for power now, V into I. So I'll go for the SI units again after some time, but right now I'm looking for heating effect, which is basically energy. So energy, or I can write it by U, or work done, or heat energy, as you like it. Okay, so this energy is what? Power into time. Okay, so what is power? Power is V into I. So this is one of the formula for heat generated in a conductor. Another formula can be put V equals to IR. So I'll get IR into I into T. So I'll get I square RT, not R square. This becomes I square RT. This is the value of heat generated. I can also put I to be equal to V upon R. So I'll get V into V upon R times T. So this will give me V square upon R into T. So we have these three formulas for heating effect or the heat generated in a circuit having voltage, current resistance, voltage resistance, right? Similarly, you can find three values for power. Either it's VI, or put V equals to IR, I'll get I square R, or put I is equal to V upon R, so I'll get V square upon R. So I also have three formulas for power as well, alright? And this is the power associated and heat generated in a circuit.